So here we have a few more examples on how friction is applied in a situation. We have a man pushing on a 25 kilogram box on a level surface from rest with a force of 110 newtons, and after 5 meters the box is moving at a speed of 3.5 meters per second. What's the coefficient of kinetic friction? Alright, so there's a lot of information given here. We have the mass given as 25 kilograms. It's on a level surface, which means our normal force is going to be pointed upward because our surface is horizontal. It starts from rest. That means our initial velocity is going to be 0, and it says after 5 meters, so our displacement's 5 meters. After that, it's going to be 3.5 meters per second. That means it's going to be the velocity afterwards, which is our final velocity. And it says we're applying a constant force of 110 newtons.
So we go ahead and list all the information that we know. We know that force 1 forward is going to be 110 newtons. We know that it's going to be displaced 5 meters. The mass is going to be 25 kilograms. The initial velocity is going to be 0. The final velocity is going to be 3.5 meters per second. Now the problem says what is the coefficient of kinetic friction, but I'll tell you right now we need to find the acceleration first. In order to find the acceleration, we have to use the information that's given to us to determine the acceleration. The kinematic equations will help us to do that. Now this represents our free body diagram. We have normal force upward. Since we're dealing with a horizontal level surface, the normal force is going to be upward. The force 1 that's being pushed on is going to be pushed to the right. The force of friction is going to be to the left, and then gravity is going to be pulling it down. So to find that acceleration first, we're going to use this equation. The final velocity squared is going to be equal to initial velocity squared plus 2 times acceleration times displacement. We go ahead and plug in our numbers, and we find that our acceleration is going to be equal to 1.225 meters per second squared. Now that's just using the equations from our first and second unit, so that's nothing new in this unit. But in order to find our coefficient of friction, we need to know two things. We need to know the force of friction, and we need to know the normal force. Okay, so our equation says the force of friction is going to be equal to coefficient of friction times normal force. So what we're going to do is we're going to first do Newton's second law in the horizontal direction to find the force of friction. All right. Well, there's only two forces in the x direction. That's force 1 and force of friction. Force 1 is in the positive direction. Force of friction is in the negative direction. And that's where this negative comes from. Where this minus comes from is because the force of friction is to the left. So force 1, which is forward, minus the force of friction because it's backwards, is going to be equal to mass times acceleration. Well, we have the acceleration. We just calculated it. It's 1.225. Force 1 is given to us 110 newtons. And then the force of friction is going to be our only unknown when we plug in those numbers. So we isolate our variable. We take 25 times 1.225. That's going to give us 30.625, and then we take the force of friction over to the other side and isolate our force of friction. We get 79.375 newtons for our force of friction. Now we need to determine the normal force. So we got the force of friction. We need to determine the normal force. Normal force is going to be in the y direction. So we do Newton's second law again, but this time we do it in the vertical direction. And the vertical forces is the normal force and the force of gravity. So we're going to take normal force minus the force of gravity, and that's going to be equal to mass times the acceleration in the y direction. Now notice something. The acceleration is completely horizontal in this problem. All right, we're dealing with a horizontal surface. The acceleration's in that direction. There is no vertical acceleration. This is where I see a mistake a lot of times, is that people will plug in this acceleration for the y direction also. That's incorrect. There is no acceleration in the y direction. All the acceleration is horizontal. Another mistake I see is that people plug in for the acceleration in the y direction 9.8 because that's the acceleration due to gravity. The problem with that is this box is not actually falling. If this box were falling, then I would say, yeah, the acceleration in the y direction is 9.8 meters per second squared. But since it's not falling, there is no acceleration, then the net force is going to be equal to 0. So normal force minus the force of gravity equals 0. We know that the force of gravity is equal to mass times the acceleration due to gravity, so that's 25 kilograms times 9.8. And then we find that that's going to be 245. We take that to the other side. We find that our normal force is 245 newtons. So now that we have our force of friction, we have our normal force. We can plug both of those into this equation to find the coefficient of friction. So the force of friction, we take the normal force to the other side and divide. So that's going to be 79.375 divided by 245, and that gives us a coefficient of friction of 0.324. And there are no units and there's no negative. It's just a number. It's just a coefficient, which is a ratio.
In this example on page 188, number 4, it says suppose that we have a 120 kilogram crate resting on a wooden floor. The coefficient of static friction is 0.5. The coefficient of kinetic friction is 0.3. Part A says what's the maximum force you would need to exert horizontally on the crate without moving it. Part B says if you continue to exert this force, once the crate starts to slip, what would be the magnitude of the acceleration? Okay, so Part A says the maximum force. Was the maximum force needed to get the crate to start moving? In order to do that, we have to apply a force that overcomes static friction. So we need to determine how much friction is being applied, or how much static friction can be applied. Now, as I apply more force, friction is going to apply force against me to match me up to the maximum amount. So, since the crate is not sliding yet, then that means that the force of friction less than or equal to coefficient of static friction times normal force, because we're dealing with static friction. There's another equation if we are sliding that we use kinetic friction. All right, the maximum amount of static friction is going to be equal to coefficient of static friction. So the force of friction is going to be whatever it is to balance me up to this maximum amount, but the maximum amount is going to be equal to this coefficient of static friction times normal force. Well, in order to solve this, I got static friction, coefficient of static friction, but I don't have the normal force. So I need to do the net force in the y direction in order to determine the normal force. We have this force 1 we're applying forward, this force of friction backward, gravity's pulling down, normal force is upward. So the net force in the y direction is going to be equal to mass times acceleration in the y direction. Well, we're not accelerating in the y direction, so we go ahead and plug that in as 0. But we do have this force of gravity downward, so we make that negative, and then this normal force upward is going to be positive. So force of gravity is going to be mass times gravity. We have an equation for that. This side of the equation is going to be 0. So we go ahead and plug in mass times gravity. That's 120 times 9.8. And we get 1176 newtons, and we go ahead and take that to the other side, so that gives us normal force. Now we could take that normal force and plug it in, and we get 0.5 times 1176. Now 0.5 is because that's our coefficient of static friction, so not the 0.3 but the 0.5. Multiply that by 1176, and we get that the force of friction is going to be 588 newtons. So that's our maximum amount of static friction. That's the amount of friction that we have to overcome in order to get it to start sliding. Now part B says now that it is sliding, we're going to apply this 588. We're still applying that to get it to start to slip, and we're still applying it to accelerate it. Now we have kinetic friction because it's sliding. As it's sliding, we get force of friction equals coefficient of kinetic friction times normal force. So we get force of friction equals 0.3 times 1176. That means our force of friction is going to be equal to 352.8 newtons. All right, to figure out the acceleration, we need to take the net force in the x direction, because that's the direction that it's accelerating in the x direction, so we need the net force in the x direction. Well, the forces we have in the x direction is force 1 and force of friction. Negative force of friction because it's in the negative direction. Force 1 is positive because it's in the positive direction. That's going to be equal to mass times acceleration. Force of friction, we already figured that out. That's 352.8. And then the force 1 that we have to apply, it says if you continue to exert the force once it starts to slip, that's this maximum force that we used back here to get it to start moving. We're going to apply that force and continue applying it, so that's 588. And that's going to be equal to mass times acceleration. So we add these together on this side, then we divide by 120, and that gives us that our acceleration is going to be 1.96 meters per second squared.
For our next example, we have a shuffleboard disc with a mass of 0.25 kilograms that's given a speed of 5.8 meters per second and then released. Now keep something in mind, the 5.8 meters per second is the velocity that it's given. So there was a force that was applied to this disc in order to give it that speed, but then it's released. So what we're looking at is we're looking at what happens to it after it's released. It says if the coefficient of kinetic friction between the disc and the concrete court is 0.31, what is the acceleration of the disc after it's released? And then after that, we'll figure out how far the disc goes when it comes to a stop. So keep something in mind on this. The first thing we need to do is we need to identify or figure out what the acceleration is going to be. And in order to figure out the acceleration, you can see that we have forces applied, which means we're going to use Newton's second law. But before we start Newton's second law, we're going to deal with a free body diagram in order to help us with Newton's second law. So the forces that are applied to this disc, if you look at it, there's an upward force applied by the surface. That's a normal force, and then a downward force of gravity because the weight of the object is pulling it down. There's no forward force because it was released, so that forward force is now gone, but we do have a force of friction. So our free body diagram looks like this, where we have a normal force up, a force of gravity down, and then the force of friction back the other direction. All right, so since we're looking for the acceleration, then that means we're looking in the x direction because that's the direction it's accelerating. It's actually going to slow down as it's moving forward. Okay, so we do Newton's second law in the x direction, the horizontal direction. The net force is going to be equal to mass times acceleration. The only force we have in the x direction is the force of friction. And the force of friction is to the left, so it gets a negative sign. So negative force of friction is going to be equal to mass times acceleration. Now we're looking for the acceleration. We have the mass, but we don't have the force of friction. Now at this point we have an equation for the force of friction, and that's going to be the coefficient of kinetic friction times the normal force. So our force of friction equation is going to be coefficient of kinetic friction times the normal force. Well, we have the coefficient of kinetic friction, it's 0.31, but we don't have the normal force. So now we need to go and find the normal force, and we know since we have our free body diagram to find a normal force, we've got to use Newton's second law again, but this time the Newton's second law is going to be in the y direction, so the net force is going to be equal to mass times acceleration. Now remember, the horizontal direction is going to be the direction of the acceleration. There's no vertical direction. So the force, the normal force upward and the force of gravity downward, those are going to be our two forces that are in the y direction. Force of gravity is going to be negative because it's downward. And there's no acceleration because it's not falling and it's not accelerating up, it's just accelerating in the x direction. So normal force minus the force of gravity equals 0. The force of gravity is going to be equal to mass times the acceleration due to gravity. We have an equation for that. The mass is going to be 0.25. The acceleration due to gravity is 9.8. So we multiply those together, we get 2.45, and then take that 2.45 to the other side, and we find that the normal force is going to be equal to that 2.45 newtons. All right, so now that we have our normal force, we can plug that in and find the force of friction. So our 0.31 times 2.45, that's going to give us our force of friction. Our force of friction is going to be equal to 0.7595 newtons. And then we can plug that in back into this equation along with our along with our mass in order to find our acceleration. So if we divide both sides by 0.25, we find that our acceleration is going to be equal to negative 3.038 meters per second squared. So using Newton's second law, we were able to figure out the acceleration. Now this was a little tedious. It had a lot of moving parts because we had to use this to figure out that we don't know the force of friction, then use the force of friction equation, and then we had to find the normal force using Newton's second law in the y direction. So after we found that, then we could go back and plug into each of our equations. Now the second part is how far is it going to go? So what's the displacement going to be? Well, we just figured out the acceleration. We know the initial velocity is 5.8, and then it's going to come to a stop. So we know the final velocity also. So knowing the initial velocity, the final velocity, the acceleration, to find the displacement, we're going to use this equation. Final velocity squared is going to be equal to initial velocity squared plus 2 times acceleration times displacement. All right, so we plug in our numbers. 0 is going to be the final velocity. The initial velocity is 5.8. Acceleration is negative 3.038. We go ahead and plug in our numbers. 5.8 squared is 33.64. 2 times negative 3.038 is going to be negative 6.076, and then we take that 33.64 to the other side, becomes negative, then we divide by our negative 6.076, and that gives us our displacement is going to be 5.54 meters.